All right, so we're going to talk about the molar mass and what that means. The molar mass is the mass of 1 mole of a particular substance. So how does the mass of one atom relate to the mass of a mole of atoms? Well, they're the same, but not really. So let's look over the periodic table. Okay, and we know these numbers underneath here represent the atomic mass of that particular atom. So for example, if I'm talking about potassium, I know the mass of potassium is, the average mass of potassium atom is 39.0983 atomic mass units. But Avogadro actually discovered that if he had a mole of that unit, of that atom, meaning 6.02 times 10 to the 23rd particles of potassium, they actually weigh 39.0983 grams. So that number is actually extremely useful, and that's actually the mass of 1 mole of that particular substance, aka molar mass. All right, so let's do some calculations with this and see how we can apply this. So let's say we have 525 grams of calcium atoms. Well, how many moles of calcium atoms do I have? Well, let's start out with a given, which is 525 grams of calcium. Okay. Well, we have to find the mass of a mole of calcium. So let's go back to our periodic table, and we know that we have 40.078. We're just going to round to 40 grams for every mole. So we have 40 grams for every 1 mole of calcium. I put this in the bottom so I can cross this unit out. 525 divided by 40 is going to give us 13.1 moles of calcium. Okay, so I know now that 525 grams of calcium equals 13.1 moles of calcium. And that might not seem helpful now, but will definitely be helpful when you learn about future things dealing with moles. Let's do another problem. 25.0 grams of gold atoms. How many gold atoms is that? Well, let's start with our given. We have 25.0 grams of gold atoms. How many atoms is that? Well, first we have to figure out the molar mass of gold. So look back at our periodic table, and we know that it's 196.9, approximately 197 grams for every 1 mole of gold. I can cross this out. So 25 divided by 197. Actually, we're not quite done yet because this actually is in moles. We want to get to atoms, so we're not actually quite done. Let's continue and say that we have, for every 1 mole, we have 6.02 times 10 to the 23rd atoms. So now we have to do 25 divided by 197 times 6.02 times 10 to the 23rd atoms. This crosses out. How many gold atoms is that? Well, we have 7.65 times 10 to the 22nd atoms of gold. That molar mass is very helpful. All right, let's say instead of atoms, we're talking about molar masses of compounds, as they're actually more typically used than the molar mass of atoms. So let's say we have 2.5 moles of glucose, or in other words, C6H12O6. How much does that weigh? Well, we have to figure out the mass of 1 mole of glucose. How do we do that? So we have to break it up into its atoms. We have 6 carbon atoms. Carbon has a mass of approximately 12 grams per mole. From our periodic table, we can note that. We have 12 hydrogen atoms. Hydrogen has approximately the mass of 1 gram for every mole of hydrogen. I'm rounding a lot here. Just bear with me. And then I have 6 oxygen atoms. And oxygen has a molar mass of approximately 16 grams per every mole. Okay. So 6 times 12, we're going to multiply them together. 6 times 12 is 72. So I have 72 grams of carbon for every mole of glucose. I have 12 grams of hydrogen. And I have 6 times 16, which is, hold on just a second, 96 grams. Come on. All right. Since they're all together in one compound, I'm going to add them all up. 72 plus 12 plus 96 is 180 grams per mole. So I know now this right here is my molar mass of glucose, the whole compound. So how can I use this? This is the mass of 1 mole of glucose. But a question asked me 2.5 moles of glucose. So what do? I do 2.5 moles of glucose, C6H12O6. 1 mole of glucose we just found out is 180 grams. Oops. So crossing this out, 2.5 times 180 is 450 grams of glucose. So we know that 2.5 moles of glucose is 450 grams of glucose using our molar mass. So this molar mass is actually very helpful when converting between units.